Hello everyone and welcome to another edition of Tech Talk Tuesday. Hi, this is Amy Hoegberg coming to you from Blue Oak Energy in Davis, California. I wanted to talk with you today about optimizing tilt angle for modules in constrained spaces. We'll start first with the graph that we have up on the left here. In most cases, we are looking to optimize the amount of energy that we can get out of a rooftop or maybe another constrained space. Given the choice, if we were at the equator, those modules would be perpendicular to the sun. That's where we're going to get the most amount of energy out of those modules. In the northern latitudes, however, we've got that sunlight coming into us at an angle. And so we want to tilt that module toward the sun, and in many cases it would be the latitude of your site that is equivalent to the tilt that you want to give to that module. So let's look at the next graph down here. We see that, let's say for Davis, California, very near Sacramento, we would start off with a module tilt of 30 degrees. We would then space the next module behind it in order to prevent shading from the first, and so on and so on. So we're building up our array on the rooftop mainly to try to reduce shading during the winter solstice, and then knowing that everything else beyond that point during the year is of a higher energy. But let's say you want to try to pack more modules into that rooftop. You know that you've got mechanical units and rooftop units that are taking up space. You've got vents that are taking up space. So let's look to see what would happen if we had those modules at a different tilt. It's basically a cosine function. If you look at the amount of energy that you would get from a module which has a 0-degree difference, or theta, between perpendicular and its normal, we would see you get about 100% of that energy. If you drop that tilt or change that tilt about 10 degrees from normal, you still have about 98.5% of that energy. If you continue to drop or take the perpendicular away from the module, you now can continue to drop that energy, but it's really not that much. You may have some energy lost due to reflection or to internal optical losses in the module, but overall it brings advantage to do that. So if we come down to this graphic here, we can see that if you drop the module tilt, again for an area like Davis, California, you can now pack those modules in. You can physically move them closer together. And when you're able to do that, instead of taking up all the space on your roof for shading, you now have more energy that's being produced. It varies greatly depending upon the roof surface, how many obstructions are there, etc. But in general, you may be able to see an increased power density of about 10 to 20%. And in terms of your yield, kilowatt hours per kilowatt peak, you might see an increase of about 5 to 15%. So I hope this lesson has been valuable for you. Thanks again for tuning in for another edition of Tech Talk Tuesday, and have a great day.